Hi everyone, Mrs. Basega here, and today I'm helping us with series and parallel circuits. A series circuit is just like this, one where the electrons go through all the wires, meeting each resistor in the series, that is, back to back to back. Notice the electrons go all the way through each of the wires, forming a closed loop called a circuit. If you're setting up this DC Circuits lab for experiment 7E, you're going to start with something like this, except you need to change the voltage of the battery to be 9 volts. So when you're bringing your battery over, you can click on it and adjust the voltage. And each of the resistors in this circuit should have a resistance of 5, 10, and 25. Now, I don't want to do one that's exactly the one for your lab, so let's pick some fun numbers here. Let's say 15, 60, 12. And let's make the battery 144 volts. So I set them all up in a series, and I'm going to change the voltage. Well, won't let me go to 144. Let's call it 120. Then make sure each resistor, so this is going to be R1, has a resistance that matches the chart. So if I make R1 15 ohms, there we go, R2 60 ohms, and R3 12 ohms. There we go. Now I want to measure the voltage and current of each bit. Remember, voltage is potential difference between 2 points. So put one side on each of each light bulb. So R1 has a voltage of 20.69 volts. Putting it on either side of R2, it's measuring the difference in potential between 2 points. So you can also think of this as a voltage drop. How much energy is this light bulb using up? Finally, R3. I'm taking these over to either side of the light bulb. This uses up 16.55 volts. And overall, we set the battery voltage to 120, but just to be fair, there we go. Either side of the battery reads 120 volts. So for voltage, use the voltmeter. And for current, use the ammeter. Ammeter measures amps. The battery's current is 1.38 amps. The first light bulb's current is 1.38 amps. The second light bulb's current is 1.38 amps. And the third. The very last corner for equivalent resistance. Use Ohm's law to calculate this corner. If the voltage is 120 and the current is 138, I can divide out to get an equivalent resistance of 86.96. Now, you're going to do the exact same thing, but with the resistors that were listed in your lab. Now let's try this for parallel. In a parallel circuit, I still have a battery. I still have resistors, and remember, light bulbs are just special resistors. I like using light bulbs in here because it helps me visually see the power. Things with a lot of power are going to be very bright because they're taking a lot of energy and turning it into heat and light every second. So notice that with parallel, I need to use a lot more wires. And that's because each of these little baby light bulbs has to make a circuit on its own. So this one is making a circuit. This next one is making a circuit. They each make their own complete loop. So I'm setting up each of our light bulbs to be on its own separate path. Then I'm going to go back and do the settings. Yours asks for 9 volts for the battery, 5, 10, and 25 for the resistors. Let's make those 120 volts for the battery. Let's make that 12, 6, and 100. So I'm going to make this up to 12 resistance. Make this down to 6 resistance. And you might notice the speed changing as this goes. You can watch the electron animation change. And what about this one? I need to bring the resistance all the way up to 100. And let's bring the battery voltage up. Let's make it actually let's make it a 12-volt car battery, so it's not too crazy. There we go. All right, so I'm measuring voltage of each item. These are the voltage drops. Think of them as how much energy gets used up by each one. So the first resistor uses up 12 volts. The second resistor uses up 12 volts. The third resistor uses up 12 volts. And maybe think about why that is. And of course, the battery was set to 12 volts. I should probably put that in the volt column. Avoid confusion. And finally, let's get our ammeter out. Ammeters measure current and voltmeters measure voltage. So the battery is putting out 3.2 amps. This first resistor gets some of it, but see how slow those electrons are going? This first resistor gets 1 amp of current. This second resistor gets 2 amps of current. And the third resistor, lots of resistance, gets almost no current at all. Using Ohm's law, I can calculate that equivalent resistance box then, because it would be 12 divided by 3.12. So the equivalent resistance is 3.85. Notice that the equivalent resistance, the 3.85, is smaller than the smallest resistance in the set, and our smallest resistance was 6. All right, so use the numbers in your lab, not the ones I just made up now, with the 5 and the 10 and the 25, the 9-volt battery. Make series and parallel resistors, then measure their voltage and current. Best of luck.